Imagine a situation where every developer has their own copy of the database. It very soon becomes untenable for every developer in an organization to have a 3 or 4 terabyte database just sitting around in Amazon RDS or locally even. It's really just not possible from a cost or space perspective.
This is DevOps Paradox, episode number 124. Fake data rules the world. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Today we have a guest on with us. We have Adam on from Tonic.ai. Adam, how you doing?
Doing great. Thanks for having me, guys.
Now you might be asking, what is Tonic.ai about? So Adam, you have the floor. Give us the 5-cent tour of what Tonic can do for someone from a data perspective.
Certainly. So Tonic.ai is the fake data company. We take an existing set of data. It could be data in a Postgres database, a SQL Server database. They could be flat files sitting in S3 or HDFS. And we find the sensitive parts of that data. We de-identify those sensitive parts and give you a new data set, which structurally, schematically, statistically is identical to the source, but all of the sensitive data has been de-identified. So the consumer of a Tonic output database won't know they're even using fake data, but it is fake data, and then they can use that data without worry for compliance and regulation and privacy and ethical concerns.
Good nickel tour. Why does this even matter to anybody?
It matters because over the past few years, and really it's been happening for more than a few years, but it's really picked up in the last few years, there's a lot of regulations relating to data. GDPR is one we all know. Going back a little further is HIPAA, related to healthcare data specifically. And now even individual states are coming up with their own regulations around data, specifically sensitive data. I might use the terms PII and PHI today. Those are just different acronyms for different types of sensitive data. But with these regulations, there's now restrictions on who in the organization can access this production data and how they can access it and why they can access it and what types of red tape and auditing need to be present to access it. So if we can use instead as developers a data set that's identical to the production data set, but all the data in it is fake, why not use that so that you can basically have all the same benefits of using the production data, but it's not actually the production data? Because the alternatives are much more difficult to work with and they're hard to use.
So what would be the major use case? I can easily imagine testing, right, as being very high on the list and obvious. Is there any other usage, less obvious, of hiding data?
Yes. Yeah, there certainly are other use cases, but you're right. Application testing and development is certainly a very large use case. A few others, though, that you might not consider would be data for sales demos, data for machine learning training and model validation, things like this. It all comes down, though, to there's people in the organization that should not have access to production data, but they need something like it to do their job. So Tonic can come in and alleviate that pain by de-identifying the sensitive information, but still maintaining that look and feel. And that really unlocks a lot of productivity benefits for the organization.
So how does it work? Do you create a copy of data, or do you intercept requests and modify the response?
So typically it's done by creating a copy of the database. The reason normally is because imagine you're a developer, you're in your development or your staging or your local environment. There's some mechanism by which your application can be pointed to a database. That database then being used with the application to do your development and testing. By creating a copy of the original data set and maintaining the schema and structure of that data set, it's simply a matter of repointing your application at this new database. From an experience point of view, it's really ideal, especially when you're trying to generate new data sets for different environments.
So it's something like I need to test something, I create a backup, I restore a backup, except that backup contains obfuscated data, something like that,
Precisely.
Right?
Yes, exactly.
And do you slice it somehow? Let's say that I work in a big company. I need data for testing, local, remote, whatever. I'm not going to have, I don't know, what is bigger than petabytes? Petabytes of data,
maybe.
right? Exabytes
Right.
of
Yeah,
data,
yeah.
whatever
Right.
it is, right? I can imagine that even before we reach the thing of obfuscating data, I'm not sure whether that's a good term, so correct me. It's about also figuring out, hey, how do I get data that is usable to me?
The answer to that question is yes, but also that it depends a lot on the underlying data source. Imagine, for example, your application database is a Postgres database. Well, a relational database like that has a notion of foreign key constraints. Basically saying this table is a foreign key constraint to this other table. So when the foreign key ID is 10, there must be a primary key of 10 in the other table. To your point, though, a lot of organizations do have tremendous amounts of data, and they don't necessarily need all of that in their lower environments. So when you're talking about the Postgres database, yeah, it's great when you can go in and delete a bunch of data, but still keep it statistically representative of what's in production. The problem, though, are those foreign key constraints, because you can't just willy-nilly go and delete a bunch of data. You're going to violate your constraints. So the foreign key constraints are the problem, but interestingly, they're also the solution. By making use of your foreign key constraints and by essentially deleting or removing data in very specific ways, you can actually use your foreign key constraints as a guide for how to remove rows. And that's actually the approach that we take. Typically, this type of tool would be called a subsetter or database subsetting. That's typically the terminology that I've seen. And it's a very common use case because, like, as you said, okay, your production database is maybe 4 terabytes. 3 terabytes of that is data, 1 terabyte is indexes. But really, in a development environment or even a local environment, do you really need 3 terabytes? The answer is often no. Imagine a situation where every developer has their own copy of the database. It very soon becomes untenable for every developer in an organization to have a 3 or 4 terabyte database just sitting around in Amazon RDS or locally even. It's really just not possible from a cost or space perspective.
Yeah, I mean, when you say kind of like, do you really need, I don't know how many terabytes? I mean, let's start with my laptop having 1 terabyte to begin with. And then when it's empty, and it's not.
Yeah, I know. When I bought my recent laptop, I made the mistake of saying 500 gigabytes was going to be a perfect amount of space. I would never need more than that, and I'm constantly having to go through and delete stuff because I'm already running out of space. So yes, you're right. When you want to have like a local version of your database, anything over like 100 gigabytes or that's probably even too much is really just not realistic for a developer. So using some type of subsetting technology is really crucial before you apply the de-identification rules.
So I was curious, kind of, what would be the order of doing those things? Do you cut it first and then, how do you say, fake it? By the way, when I heard at the very beginning you said fake data, my first association was, okay, if somebody who is not in our industry heard that, they would already associate it with fake news and you would be in deep
Yes,
trouble, man.
it is. It's certainly a catchy slogan. I didn't come up with it, but yeah, I certainly agree with you. So the order of operations, it can be done in a variety of ways. For example, you could just subset your data, and then that's kind of your seed. And then you have different de-identification rules based on use case that are all operating from that seed, creating new copies. That's perfectly viable. Depending on your workflows, that might be even preferable. Another option is that you just subset and de-identify all at once during a given run of your subsetting and de-identification. So it really is going to depend a lot on like exactly what you're going for, like how many people are in your organization, how many different sets of de-identification rules do you have, and then you'll be able to come up with the appropriate order of operations.
What's the common modus operandi? I can imagine companies making a backup every day or every week with fake data and kind of like, hey, it's over there, use it.
So the frequency at which you want to do these things is going to be highly dependent on really two things. One, how quickly the schema of your database is changing, right? Because as soon as the schema changes, the application is expecting a certain schema. So when a new table is added, you need to redo your run so that that new table gets into your output database so that the application doesn't just completely vomit when it boots up. Then the other thing it will be a function of is the amount of data being added to your new database daily or weekly or whatever cadence there is. If you have, because of your testing or your product or your industry, a high sensitivity to always having the latest data when doing your development and testing, then you might need to run a product like ours more frequently. Take that also with the fact that this isn't only used on application databases. This is also used in data warehouses. Data warehouses, they have a lot of data sitting there today, but then they have new data coming in quite frequently. So you might need to be de-identifying data nightly or weekly, depending on how your data warehouse is partitioned, for example. There can be a lot of factors at play here.
If you talk about something relatively big. Maybe not Google size, but getting there. That must be easy demanding on the resources, on time and all those things. If you have petabytes of data and an average amount of rules or whatever they're called, kind of like, is that, hey, done?
Right.
Or
So, yeah, no, physics, unfortunately, won't allow it to happen with the snap of the fingers. So, from a performance point of view, it depends a lot on the database technology, or rather the storage technology. And really, the bottlenecks that we typically find are more on the database side and the network side than they are on the actual processing side. From a processing point of view, you can typically scale these types of things horizontally or vertically to be able to basically increase your compute. But if you're just trying to insert data into a SQL server, for example, you're going to get constrained there at some point, and those are typically where the bottlenecks are. But that's for like relational databases. When you're talking about things at the petabyte scale, oftentimes, at least in my experience, you're talking more about like things like data warehouses, like files sitting in S3 processed by Databricks, or a very large Snowflake cluster, or things like this. And those are less constrained on the database or storage side. So typically, you can just scale up compute to be really as fast as you would like it to be. And really, it just becomes a question of how long do you want this to take and how much do you want the job to cost?
I want to go back to subsetting for just a second. We've got a 5 petabyte data store. Take your engine of choice, doesn't matter. You've already mentioned that storage is one of the bottlenecks and that networking is one of the bottlenecks. If I'm trying to subset something to get it down to an application developer, should they even really be running a database locally? We all know that, yes, we want to run everything locally because we can go fly on an airplane and keep working. It seems to me that subsetting would be almost too random to get it to a size that's usable.
Got it. So I think I have to answer your question with a question. What do you mean by random in this case?
If we are de-identifying, which I like that's better than anonymizing, but de-identifying data, I don't need everything. I would expect a proper sampling, and you've already talked about the foreign key constraints, so you should be bringing along all the children, whatever that is. But it seems like at some point, when you don't have foreign keys set up correctly, that you're going to have a mismatch at some point. And for things that were implicitly foreign keyed, just not explicitly foreign keyed.
That's right. So we certainly need to make a distinction here between foreign keys that exist in the database system itself, which are really foreign keys, they're foreign key constraints, and I guess what I'm going to call virtual foreign keys, these implicit relationships that the application assumes exists, but they're nowhere enshrined in the database itself. In situations like that, at least in the subsetter that Tonic provides to its customers, I can't speak for other subsetters, we actually have a notion of virtual foreign keys. The user of Tonic can go add these virtual foreign keys into the product, in which case Tonic will treat them as if they were actual database foreign keys. Does that answer your question?
Yeah.
yes, but
Great.
that brings another question from my side.
Great.
If I would define virtual foreign key or whatever you call it in Tonic or whenever, right? Because I'm missing it in a database. Shouldn't I do that inside of the database? Assuming that we're talking about a database that does have foreign keys.
Well,
kind of,
the silly answer to your question is I don't know. You should go ask your DBA.
Okay.
The more serious answer, and full disclosure here, I am not a DBA, so anyone listening to this should not take this too seriously. There can be drawbacks to having foreign keys in a database system. They can slow down performance because they often require an index to be created, and indexes can slow down inserts, for example. There are valid reasons not to have it as a foreign key in the database system, but only in the application layer. And I'm sure there are other reasons, but I don't know them.
Now give us a hard example. Let's break out some more of your acronyms, your PII stuff. I know what it is because I've dealt with it. But for people that don't understand what PII is, set up an example for us of, okay, here's where we're starting and here's where we're going with it.
I want to think of a good example for you, and hard as you requested. Okay, you know what? I'm going to not listen to your question. I'm going to start with an easy example and we can build it up. I think that's going to be a little easier for me to come up with something on the fly like this. Starting off, let's say we have a customers table or a users table. It has the things that one would expect. It has their first name, their last name, their email address. Maybe it has a foreign key to an address table, which contains address information, right? It has their SSN, things that are obviously sensitive. The first thing we got to do is we got to go in there, and all of the columns I just mentioned, we likely need to apply transformations. And you're like, okay, well, I can write a function to come up with new first names. That's not that hard, right? I can go find 20,000 random first names on Google. I can put it into a CSV, shuffle it around, and just sample from it at random. I'll actually say that it's actually a lot harder to do than you think right off the bat, even though it's an easy table. And I'll tell you why. Let's say, for example, that you're a larger organization, but honestly, you don't even need to be that large. Yeah, you have this customers table, but you also have the names of your customers in 10 other tables in the same database. You have them sitting in a different database, like literally one database is Postgres, the other SQL Server, because you're in the middle of a migration. And you have some of these names sitting, for example, in flat files. Maybe they're Parquet files or CSV files or Avro or Orc or whatever. We already have a problem, right? Not only do we have to randomly pick new names, but we have to basically do it in a consistent way so that when we go boot up our application and point it at the test data, things will still make sense and they'll work. So my name is Adam. So there's the name column and it's Adam. Whenever we see an Adam, we want to replace it with the same fake name everywhere so that the data will still link up and have the correct associations between it when you go to do your development and your testing. Now, doing that for all the Adams in a single column in a single table, yeah, you could do that programmatically pretty easily. It gets a little harder when it's between two different tables in the same database. It gets very hard when it's between two different relational databases. And then it gets even harder still when there's some Adams sitting in a Parquet file in S3 somewhere. So coming up with that consistent mapping is already a hard problem. And you'll find that a lot of columns require that notion of consistency for things to work. Already, we have the easy example of the customers table where there's obviously all the types of PII, and you already have this difficult problem you have to solve that you might not realize exists when you first start trying to solve it. Does that begin to answer the question for you?
Yes. So you're saying that the first name being a personally identifiable information piece of data, PII, you wouldn't think that first name's that big of a deal, but it is. I'm leading into a little bit more. All of this comes down to security. Even if I'm de-identifying data, it seems like even through that de-identification, we still potentially could have leakage of legitimate data if it could be figured out how to reverse it back to identifiable.
Certainly. Additionally, you can, when using this notion of consistency, open yourself up to a frequency attack, for example. You have one person in the column that appears 10 times more frequently than everyone else. I mean, that's a big fat outlier right there. So you need to be careful there. First of all, let me say, with any tool that is going to do this for you, you as the end user are always having to choose a balance between data privacy and data utility. You turn the knob one way, you get more privacy to your data, but the utility drops. So then you got to turn it the other way to make the data a little more useful for whatever your task at hand is, but the privacy has gone down. So it's about choosing where the balance is going to be for your use case and what you're trying to do and what your threat model is and how you think an attack might come or who it might come from. With that being said, there are techniques that one can use to try to mitigate these risks as well.
What are some of those options?
So there's a whole suite of, or whole set, I shouldn't say suite, a whole set of research out there around privacy and coming up with mathematical formulations for how to keep things private. One that Tonic employs for a variety of our transformations is something called differential privacy, which allows the user of these differentially private algorithms to maintain a sense of plausible deniability in terms of what's real and what's not in your output data set.
I like plausible deniability. That's good. Can you give us one more tool that I can use to help manage that risk?
Another type of privacy framework that's out there would be something like anonymity, which essentially, I'm going to do a bad job at explaining this. I encourage everyone listening to go Google it after I'm done. Basically, any individual person can only be bucketed into a group of size K or larger so that no one can really be identified down to a sufficiently granular level to basically attack them.
Victor brought up at the beginning, are you doing this basically offline or how do you do it online? And right now, everything you've talked about is completely offline. I got a snapshot, it gets de-identified, and magically, here's your new data set to go play with.
So when you say offline and online, you mean the data is already at rest in a database or
Yes.
online being it's streaming?
Correct.
I thought you were talking about on-prem versus SaaS or things of that nature. Okay.
No. So is that correct? So it's the only time you're dealing with data, at least today, is through at rest versus streaming.
We do have an offering for the streaming use case, but it's done through more of a SDK approach that we offer. It's a bit different than the data at rest approach. The transformations in the tooling is all the same. The experience is almost roughly the same as well. But historically, we focus mostly on data at rest.
I want to go back to the streaming thing for a second.
Sure.
If people are wanting data anonymized on the fly, de-identified on the fly, I can't think of anybody. People will say they want it, but I can't think of a good use case for it. Have you seen a good? I mean, obviously you have an offering around it, so there is obviously a use case for it, but I can't see it in my head.
So the offering we have around it is it's not exactly for this online streaming. It's tough to explain without getting into the weeds. It is essentially a Java SDK that can be used in conjunction with things like Spark and HBase and Presto, where it provides essentially tonic transformations as what are called UDFs, user-defined functions, so that you can basically wrap your data, and when it gets written, it'll go through these tonic transformations first. But it can also be used with technologies like Kafka, which supports streaming. But it's not really common. And yeah, coming up with a use case, let's see. An example might be, let's say you're trying to test an event pipeline. And so, you need synthetic or de-identified or fake events coming into the pipeline so you can test what happens as events come in. And you might want to use de-identified data for that. This is not a use case that I've really encountered before. So I'm kind of just spitballing here with you.
You just triggered something that was thought about earlier. Today, you take at-rest data and subset it and then de-anonymized, and I go from 6 petabytes to 10 gig. Right? Okay. That's your bread and butter type stuff.
Yeah, I think that's fairly reasonable to say, yes.
So what if I had 10 meg of data and I needed 60 terabytes of data from that? Let's go the other direction.
Yes, that is certainly a thing. You could make it even more extreme. Let's say we have no data. What do we do? Interestingly, actually, that is even more extreme, but the way that I would solve that is going to be very different than when I have at least a base of data to work with. When you have at least some data to work with, that's really good, because then you have something to model the interactions and relationships between your columns off of. In our product, we call this synthesized mode, where instead of de-identifying data, and it's like a mapping of like, okay, this row becomes that row, this row becomes that row, we're instead just taking however many rows of data and synthesizing net new rows, where each new row doesn't really associate to a specific row in the original set. It's just synthesized from presumably nothing, but really it's created based on the relationships that exist in your base set of data. There are a few approaches to this problem. One option would be, for example, you have this really simple customers table, right? You got your first name, your last name, your SSN, your address, your phone number, etc. Well, Tonic has transformations where we'll just generate fake first names, fake last names, fake phone numbers, etc. And we can generate an arbitrary number of them. Okay, that's fine. Okay, well, maybe there's a problem, right? Let's say there's a foreign key on the table. So we do have to do work to ensure that when we're generating the column that's the foreign key, that we're actually sampling in a statistically accurate way from whatever the table is that the foreign key references, which can be very challenging to do. Imagine an example where you have two tables. You have a users table and an events table. And the events table has a foreign key back to the users table. And it turns out in this data set or in this database that most events are generated by a small percent of users. These are your power users. And maybe the distribution of number of users that generate X events, maybe that's like a power law distribution. We want to be able to preserve those types of properties when we're synthesizing a new set of events or a new set of users. There is certainly a lot of complexity there, especially when you start involving inter-table relationships. Another approach to this, it's a relatively new thing. Well, it's relatively new. Like the research behind it is I don't know how old it is, but the research that I'm aware of is only maybe 2-3 years old. You can actually use, and another caveat here, I'm not an expert in this. You can use generative adversarial networks to actually train on your base set of data and then generate new rows of data that should statistically represent the original. And that would be like the alternative approach to attempting to manually apply transformations on all of the columns. We work with both approaches.
Which one is more fun to you? Going from large to small or going from nothing to huge?
I think going from large to small is more fun because it is a far more in-demand feature. It is far more requested by people. And I can easily understand why customers need to go from large to small, just for the reasons that we mentioned earlier. Going from small to big it's not as common a thing, I would say. And I like things that make customers happy and that people want to use them. So, it's always more fun.
I would have made the same guess. From big to small makes much more sense. But now while we're talking, I have a feeling that I'm starting to see how small to big might have just as much sense or even more. Because when you think about it, whenever you create a new table or even add a new column and you want to release it to production, you want to test it, right, properly. And by properly meaning how this will behave in production, not how it will behave when I put Joe and Michael into my database, 2 rows, and that's about it, right? I understand how big to small is obviously meant, but small to big sounds like untapped potential in a way, right? For all the new feature development.
I'm going to point something out based on what you said. Let's go through the scenario of a new column has been added to a table. And before we push it to production, we would like to generate a fake database that contains fake data, including this column. Well, you don't actually need to be in this synthesized mode or use these synthesized techniques to do that. The table already exists, but initially the column's all null, or it's all an empty string, or it all defaults to an integer value of 0, or whatever it is. You can apply transformation to the column to get what you want in there. You don't have to use these synthesis techniques. Synthesis really operates on an entire table at once when you want to generate an arbitrary number of rows, not when you just want to populate a single column of data in a table, if that makes sense.
True. I was more thinking about, hey, if I do this, whatever that is, like create a new table, whatever, I would like to know how it will behave after it is running in production and being hit by million users. Not that much about how to populate that table or column or whatever with nulls or whatever.
Yes.
I'm going to have that. I know that. But it's similar to, in a way, or maybe for, let's say, performance testing, right? We're all trying to figure out how will that behave when it gets hit really hard, right?
Certainly. And that use case, everything you've just said, is typically the main drivers that we see for folks that want to do this pure synthesis. So I agree with everything you've said, yes. With that being said, it is less common than going from big to small, as Darren said.
Yeah, I mean, it makes sense. Small to big is always a subset going to be from big to small, whether that subset is 90% or 10%, but yeah.
That's right.
People just don't realize that they need small to big, I think. You said it's a smaller business case for you, but to me, it should be probably the largest. Because if people are expecting to grow, they need to know how to scale their application. They need to understand what's going on with the database. Once it crosses that magical, whatever that is, at some point, there's a tipping point to where the indexes are no longer performant. You have to re-index every stinking table. Do you want to ask me how I know that? Or when you're all of a sudden, you've been fine on spinning platters up to a certain point, and then all of a sudden, SSD is no longer even good enough. So being able to basically have an infinitely scalable data set, to me, is more important than scaling down so a developer can actually get his work done.
Do you think for the scalable data set, do you think, like for the use cases that you've seen in the past, does the quality of the data matter as much when compared to like the data that you would want to use for application testing?
Define quality.
How realistic it looks compared to compared to the real data?
It's actually huge.
What's huge? I'm sorry.
The importance of quality data is a very, very important factor.
I would posit that when you begin scaling data up and starting with a small data set, I think typically you'll find that the quality of the data might be less than what it could be if you were going the de-identification route and not changing the number of rows, or if you were just subsetting. That can be a problem.
Like you were saying earlier, when you're synthesizing data and you're trying to get the scaling right. So going back to, I've got a user, and on average, users only have 5 events. I'm making up real numbers for you against what you were talking about earlier.
Sure.
But then you have 20% of your users have 1,000 plus events.
Right.
So having that data correctly available is a huge deal. Because it's easy to go in and say 1 to 5, 1 to 5, 1 to 5.
It's
not as simple to generate the data that's, I'm going to use the word randomized incorrectly there, but statistically making sense.
So when you say the quality of the data is hugely important, I agree with you in the case that you just brought up. In my head when I asked the question, and I didn't really formulate this, I was more thinking of like, imagine a table of incomes, right? And it has your income and the city in which you live. And in the real data, the average income in San Francisco is higher than the average income in Atlanta, Georgia. Do properties like that matter for this type of load testing? Or is it more just about like the ratios between table sizes and these distributions of foreign keys and things of that nature?
Yeah, it's the actual data doesn't matter as much, but the representation of the distribution of the data is huge.
Well, yeah, then we're in 100% agreement. Yes.
Rats. I was hoping to be able to fight with a guest. Yeah.
What's that?
So I was hoping to be able to have a fight with a guest.
Well,
that's not going to happen.
Make it go viral.
No, we won't go viral. We don't use the V word anymore. We also don't use the P word, which is pivot. We don't use viral. We don't use pivot. We're past the pandemic times of the name that we'll no longer name.
That's very good.
If people were wanting to try to figure out, okay, how can I do this? What's the easiest way for somebody just to, maybe they'll take a look at Tonic. It's like, hey, look, I don't really want to go with Tonic right now. I don't want to give them an email address, right?
Sure.
Okay, fine. Where could somebody just start? I mean, if somebody's trying to get started open source wise, what would be a good place for them to just sort of, you're not going to get the full Tonic experience, right?
Understood.
We're not even talking Tonic. What can somebody do from an open source perspective just to sort of like, I need to roll my own right now?
On our blog about, I think it's probably 2.5 years ago, I wrote an article on using Python with Faker, which is a Python library for generating fake data, and how you can use it to achieve a small subset of the functionality that we offer in our commercial product using only open source software. I think that would be a great place to start.
So if people wanted to get in touch with Tonic, obviously it's Tonic.ai, but if they have questions for you, what is the best place for people to contact you at?
Do you mean me personally?
Yes, because everybody wants to talk to you because obviously you're an engineer and you've used big words. By the way, we haven't said it yet. Adam is a PhD. Having his PhD, he's smart. He knows what's going on because how much of the code do you think you've written behind the scenes for Tonic?
Oh, man. If you'd asked me a year ago, I'd have said a lot. At this point, it's a lot less because the engineering team keeps growing.
But you understand it. So if people are going to want to be able to say, okay, what are you really doing, right? You just told us about Faker. Okay, what's they really doing? So if people want to talk to you, they can reach out to you on Twitter. What's the best thing for you?
Oh, man, I'm not a social media guy. If they want to reach out to me...
Oh, you're a PhD. That's right. There's no social media.
And as we discussed earlier, no sports. If they want to reach out to me, they should reach out to hello@Tonic.ai. I'm on that distribution. I respond to emails there all the time. If it's not me, it'll be one of my awesome coworkers, also fellow engineers. And if they're really excited about it, they should just go to Tonic.ai, sign up for a free sandbox, get using Tonic today, and then they'll certainly talk to me because I love talking to our sandbox customers.
How far does the sandbox go? Obviously capped on certain things, but functionally it's
functionally, I think that there's one or two databases that we don't support in the sandbox, but functionally it's like 99% there, and it's typically less popular databases anyways that aren't supported on the sandbox. The only real difference with the sandbox is that it's hosted. So we're hosting it, whereas almost all of our customers deploy Tonic on-prem.
Oh, wait. Okay. We thought we were wrapping up, and now you just said we're going on-prem. What is your deployment strategy for on-prem?
Got it. Okay. Yeah, it's a DevOps podcast. So when customers go with Tonic, we give them access to basically private Docker repositories, and then they can pull our containers and deploy them as they wish. We provide support out of the gate for deploying via Docker Compose, as well as through Kubernetes via Helm charts that we provide.
Okay, so pretty boring. Okay.
Yeah, but boring is good.
Boring is very good. Adam, thanks for hanging out with us today. If you have any questions that you want to get in touch with Adam about, we'll have the contact information down in the show notes. But in short, hello@Tonic.ai. Thanks, Adam.
Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.